Okay, everyone, just to get people started, I'd like everyone to be reminded of what's to come this week. You know that Thursday is going to be a test, but today and tomorrow is essentially review. So if you take a look at the table in the front of our class, we have a bunch of questions for today, specifically rational function equations. So you will have some kind of fraction function, rational function equaling something, and you're applying all the tools that we have learned until now to solve. Okay? Um, there is also, as you already know, a test 3 review. It's a single piece of paper, but there's got a variety of different questions you can try. Whatever works for you, works for you. What I want to focus on, taking a look at the sheet, what I have on my Brightspace might be a little bit different from this. I think on the Brightspace, I have the equation already provided within the question. I sort of retyped it, but this is the original sheet, and I thought I'd give it to you to give you a chance to create your own equation. Now, it might seem unusual, and you might have your own equation through it. This would be the correct one, but would you please try number 1 and solve it using what you know of rational functions, and then try number 2 and as an addition, and number 3, and see if you could come up with the equation yourself. You have my word that the test will not ask you to create your own equations, but I think it's good practice. Let's start our day like that. I'll give you about a good 15 minutes. At least make an attempt and even struggle with it if you wish. We'll take it all up together, and the rest of the class is yours to continue practicing. Okay, I'll pause the video. Okay, I'm gonna assume everyone had a chance to try it, so I'll unpause the video and we'll get to it. As you might imagine, Andrew, one second. As you might imagine, a lot of the questions that you see here is going to be some form of equation or an inequality. And depending on your practice, I hope you're able to figure out whether you're supposed to solve for an x or use a chart to figure out whether it's a plus or minus interval kind of question. All right, let's do it. A lot of these questions too, even AROC and IROC from last class, I'm really hoping you give it an honest approach and really just review, even if it is easy or you remember how to do it, simply because all of that AROC, IROC, all of these rational functions that we equal something, that is all a intro taste of what you will do in calculus. A lot of the calculus is literally calculating how something is changing. Is the change fast? Is the change slow? Is a change going upwards? Is a change going downwards? It's all about the change of something. And those of you who've done physics, Salt water is flowing into a large tank that contains pure water. And yes, I could easily turn this into a rate of change question because if this was a tank of water, it's all pure water, but you know, salt water is not very good. If water is pouring in, the concentration of salt in this tank is very small, but what happens as time passes? The concentration is changing. Anything that requires a change is a very good calculus question. So be familiar with these kinds of scenarios, right? Play it out in your head even before we have to calculate. Moving on. When you are answering word questions, if no one has told you before, let me be the first to tell you, you are asked to solve whatever is in the final sentence. Typically, the question mark is always in the final sentence, so focus on that. When, so that means what is T? When does the salt concentration in the tank reach 3.75 grams per liter? Okay, so C of T is equal to 3.75 grams per liter. That's our question. So let's solve it. Okay, since the equation is given, you can say if the concentration is 3.75, that is because 10 times the time over 25 plus the time equals that. From there, you're asked to solve. Once you get to this point, I'm hoping it looks very familiar to your practice, like your textbook questions. The only way we can solve it is by bringing this to one side, minus 3.75. And you may be tempted to just multiply both sides by 25 plus t, but please try to make a habit of not doing that, but instead turning everything into one giant fraction instead. It will keep you from reinforcing a habit. It's not the greatest, and it could cause potential headaches in the future, as I always say. So let's solve it. By now, here's another thing I'm going to say. Because of your practice, I am hoping that you understand what I mean or how I got to this place without me showing extra steps from the practice you've done so far. And from there, using your calculator, you should have a numerator of there. I'm seeing a few blank faces. People, all right, this looks familiar. Is everyone okay with this much? Okay. It's very hard to have get feedback when it feels like it's just a recap all over again. Because a fraction is equal to 0, I have the privilege, I guess, of only focusing on the numerator. So you can say that therefore 0 is going to be equal to 6.25t minus 93.75, which means positive 93.75 equals 6.25t. And so t is equal to, oops, 93.75, 6.25, 15. What is that? Okay. Therefore, the tank reaches this, let's say, concentration, excuse me for using some chemistry symbols, reaches a concentration of 3.75 grams per liter at 15 seconds. Yep.
Is there a reason why you didn't multiply both sides by 25 plus t?
Why I do not?
Why, like, yeah, you didn't. Is it like a bit faster, or is it?
It's obviously it's not faster, right? It's clear that it's not faster. Why would you bring it to one side and make the denominators equal to each other? The argument that I made was, depending on what this factor equals, depending on what the time is, in this case, obviously you don't want the time to be a negative. That doesn't make any sense. But in a normal question where x or t or whatever could be any number, there's a chance that you're multiplying by a negative. When that is the case, you would have to change the sign of the inequality if it's a negative, but you don't if it's a positive. So it gets really confusing, right? Of course, in this question, you can argue, since this is not an inequality, why can't you? You could. As long as t does not equal to negative 25, you can multiply both sides by the bracket. It's true.
So I need to state that if I was to do it that way.
In this case, no, because you know that time would never be a negative value. However, I'm just afraid that certain people will turn that into muscle memory and multiply the denominator no matter what. And they'll just do it as their go-to solution. And that will create errors if we're talking about inequalities.
But for equal, it's fine.
Technically, yes, it's okay. Technically, it's not wrong. But I want to reinforce this process, even using it when you don't have to, again and again and again, so that you stick to one tried and true method as opposed to, well, when it's like this, do it like this way. When it's like this, do it that way. But I'll leave that to you. You can make that decision. You guys are savvy enough for sure. So it comes to number 2. So if you were doing this at a non-grade 12 level, it is very easy for you to say, oh, well, I'm looking for how many shirts. So let X be the number of shirts in the case. And then it's very easy for you to say, okay, well, $10 times the number of shirts should be my profit, total profit. But that is equal to $560 is how much I made minus $450 is how much I spent. Therefore, 10x is equal to $110. That's not true. Why? Because the x here and the x here and the x here may not be the same. Rima bought a case of concert tickets for $450. She kept 2 t-shirts and sold the rest for $560. So if this refers to X amount of shirts, this amount refers to X minus 2 amount of shirts. And this should also refer to X minus 2 amount. There's a lot of confusing things that occur, and it's not as simple as, oh, I made $10 for each shirt that I bought originally. That's not true. So long story short, when you get a question like this, it's actually better and correct to use a unit rate model. This is what I mean. How much was made for one shirt? Well, that should be from the revenue made for one shirt minus the cost for one shirt. Because the number of shirts we're dealing with are different everywhere, it is correct to use it as a unit rate. So what's the profit of one shirt? Well, $10 a shirt. What is the revenue for one shirt? I earned $560 for how many shirts? X minus 2. How much did I have to pay for one shirt? 450 divided by X amount of shirts. So it's not as simple as the previous equation I provided. Once you have this down, and again, question 3 is very similar to this. I'd like you to try it on your own later. Once you have this equation, that is a good first step. The rest is your usual, I guess, technique for solving rational equations. So what you're trying to solve is here. Would you like some time to try it, or can we take it up? Can I take it up? Yeah, okay. Some people are just like, yeah, let's just get it over with. It's the last day of the class, or last class of the day. Let's solve it, okay? Okay, good luck. Yes?
If we end up having to make our own equations on the test, would it be this revenue or could it be whatever? Would it just be this specific thing that you're showing us now?
I'm sure there are other ways you could approach it, but make sure you are accounting for everything so you do get the same answer. Ultimately, if you make your own equation, you still should reach the same answer, which is 18, I think. So 450, X minus 2, X minus 2. Oh, I ran out of space. Minus 10, X minus 2 over X minus 2. Long story short, I have negative 10x squared. I have 560 minus 450, so that's minus 110. Plus 20, no, plus 110 plus 120, positive 130x, and positive 900, that's it. And then just like before, we can focus on this. Let me divide by a 10. I don't like that variable, and I see they are all multiples of 10. $18 and 5. Okay. So in solving this, again, I'm rushing it a little bit, I guess, right? But the process, I think, isn't a mystery to everyone. I hope that when you do get to the factored state, you are able to pull out 18 or negative 5. And because this is a word situation, it has context. The x value of negative 5 does not make sense. Remember, let x be the number of shirts. Can the number of shirts be negative 5 shirts? It doesn't make sense. So that, in our context, is what we will call an extraneous root. Mathematically, it's correct. Situationally, it's rejected. So the final answer is just that. So once again, this might be this idea of the profit of a single shirt versus equals the revenue of a single shirt minus the cost of a single shirt. It might be unusual to you, but it is absolutely necessary because they are talking about a different number of shirts in every single piece. And so you have to normalize that. You have to put them all in the same playing field, which means it results in an annoying fraction rational function. Please use this as a template for question number 3. If you can try question number 3 and solve it, the prompt, the example, the given equation is on the sheet right there, but try not to use it. See if you could read it first and give it a go. And I'll give you about 5 minutes. We'll solve it. I'll give you some pointers for the remaining questions, and then away we go. Okay, let me pause the video. Okay, let's do this. Okay, X represents number of comic books originally. Profit is there, and there you have that. So this second fraction minus $1.50 times X minus 15 all over X over X minus 15. We have negative 1.5 X squared. I'm going to focus on the numerator. We have negative 330 minus 300 is 30. Well, 150 times 15, that's a positive 22.5, so that's plus 52.5x, and then that is 4,500, and there's no x, that's a plus 4,500. Which means, so let's focus on just the numerator. 0 is equal to x squared negative 35x negative 3,000, which is the same as 130, too far away. 50 and 60, too close. 50, 60, 60, no, more 70, 75. Perfect. Negative 75, positive 40.
How do you just look at it as that?
I can explain. How do I look at it and know? The idea is this. I start with numbers that I know that work. 30 and 100, right? Is that too far away? What's the difference between these two? 70, way too big. And did I get my signs wrong? What if I added 130? So it's way off. So I need to bring these closer together. So I thought, okay, 30 is like 5 and 6. So what about 50 and 60? What's the difference? 10. Too small. So I need to find a number between 30 and 50 and 60 and 100. That's what's going through my head, at least. Right? It's not the proper way of doing decomposition, but if you do enough practice, these little shortcuts start popping up in your head. And I thought, okay, and then I tried 70 and I realized I didn't divide well, and then it became 75. But once again, if you have a negative 40, that doesn't make sense because X represents number of comic books. We can't have a negative number of comic books. We'll call this extraneous because it is an answer mathematically, but it does not fit logically. Therefore, there are 75 comics. That was part A. Part B says, what was the original price of each comic? Well, for part B, I bought each one or all 75 of them for $3,000 or $300. So if I were to divide them, it becomes $4 per one comic. There's my final answer. Okay, so to wrap up this video, so to speak, number 4, you will see that it says use technology to solve, because once you set up your rational equation, factoring, quadratic formula, none of that seemed to work. So you'll have to actually look at it and talk about it. My challenge to you for today, or rather my request for you today, is to, in the least, take a look at number 5. The answer to number 5 is never. I would like you to observe what the answer never looks like mathematically. There's a variety of ways you could get the answer never, but here's one of them. So take a look at what that looks like in an algebraic, I guess, in an algebraic scope, okay? And how we can interpret that as it will never happen. Yep. Yeah, but again, what does that look like algebraically? How do you show that in an equation? How does that manifest in numbers? Does it become a denominator of 0, like you said, right? Where it's impossible. Does it become this? Does it become that? Take a look. And when you see this, you're like, oh, that's what it means by it's never going to happen. That's what I'd like you to experience. Okay, give it a shot. I'll stop the video unless there are any questions.